All right, we're going to tackle a triple integral evaluating 6z squared, where our integral is a region bounded above by this kind of plane. So it's kind of this part in here in the first octant, and of course octant is necessary in 3D. Of course, in 2D we have quadrants, but this is where x, y, and z are all positive. And then you see down here just a sketch of what just the x, y plane would look like. Okay, now I'm going to just point out a couple of things. Being in the first octant means that z is going to go from 0, because we're just talking about that octant, up to this curve that was given. Now, whatever your d whatever is, in this case maybe dz, think about going from 0 up to this. Maybe we'll integrate first with dz. That means that if your differential is dz, only x's and y's can appear in your bounds. Because once we've evaluated, we found the antiderivative with respect to z, and we plugged in those bounds, we can't have any more z's. We can only have x's or y's, because that's all that's left to evaluate. So we're going to rewrite this equation just right away. We're going to say, okay, let's solve it for z. So imagine subtracting everything over, dividing then by 2. We would have 5 minus 2x minus 1/2 y. That would be our z equals. Okay, so again, just keep that in mind. You can only have the variables that aren't the differentiable. So then looking kind of at this piece and saying, okay, so it's this thing, and this is our base. We've taken care of the z from 0 up until that thing. That will end up being our first evaluate integral. Then I guess we have some choices. I was trying to maybe I'm going to try and avoid some fractions. So we could say, well, this is the line, 4x plus y equals 10. That is the line that makes up this piece here, because of course everything else is just against the plane. I solved it for y. Y equals, because I didn't want to have x equals 10 minus y over 4. I just thought that could add an ugliness that I didn't find necessary. So I'm going to go in terms of y from 0 up to 10 minus 4x, and then you'll notice x is going to go from 0 out to 2.5, or 5 halves. Okay, so that is going to be that's going to be my integral. So starting with z, let's kind of, that was an ugly integral sign. Let's work our way out. For z being in the first octant, we're going to go from 0 up to that thing that I just found. So 0 up to 5 minus 2x minus 1/2 y. Oops, 1/2 y. Okay, so that's dz. That's our innermost. My next integral is going to be, I said y, so it's going to be 0 to 10 minus 4x. And again, if our differential is y, dy, we can't have a y in our thing. And our final one will be numbers. Always got to be numbers. I'm going to say 5 halves. You could definitely say 2.5. It's going to be our last one. Okay, I don't know why I left quite so much room. So my antiderivative with respect to z, raise the power divided. I got 2z cubed, and I plug in, oh my goodness, this big thing here, and I plug in 0. So I get 2, and I'm actually going to write it down here so I can write the integral sign right after it. And next up, we're going to do 0 to 10 minus 4x dy. Okay. Now remember, because this looks awful. This looks like you got to actually go out and actually multiply this out. We don't. We can use some substitution here. Okay. U is 5 minus 2x minus 1/2 y. Well, remember, y is the only variable, so the derivative of that's just negative 1/2. Okay, so dy. multiply both sides by negative 2. Okay. I actually end up with a okay, so we are going to have to pick up this negative 2 multiplier out. So I'm really kind of running out of space. So let me kind of put this over here. We've got a negative 4 out front because of this 2, and then this negative 2. And then we've got u cubed du. So we raise the power and divide, right? Raise it. So we end up with just negative u to the 4th. All right? So we end up with 5 minus 2x minus 1/2 y negative to the 4th, evaluated at 10 minus 4x and 0. And let's kind of talk through this a little bit. If I plug in 10 minus 4x, so I'd have 5 minus 2x minus 1/2 of this. Well, half of 10 minus 4x is 5 minus 2x. So you'd have 5 minus 2x minus 5 minus 2x, but minus a negative. It's 0. So you have 0 minus negative 5 minus 2x minus 0. So minus a negative makes it plus. So I end up, I'm gonna put this over here where I have a little room. I end up with just 5 minus 2x to the 4th, from 0 to 5/2. Well, think substitution again. If u is 5 minus 2x, derivative of that is negative 2. So you have to divide by that negative 1/2. So we got negative 1/2 u to the 4th, excuse me. Getting ahead of myself here. Raise the power, divide. We got negative 1/10 u. I'm going to put back in the 5th. Evaluate at 2.5, 5/2, and 0. Well, of course, if I plug in 2.5 into those parentheses, I get 0. So I end up with negative 1/10 times 5 to the 5th, which reduces my final answer is 625 over 2. So here we're going to evaluate that 12y minus 8x in this region. And I have a couple of pictures here that I'll kind of quickly explain. So this is our region E. It's behind this kind of 3D, this plane. It goes back to the XZ plane, so kind of where y is 0. Okay, it's this plane and back, like I said, to where y is 0, and bounded by 2x. Okay, and z equals 5. So stopping here at z equals 5, and at x equals 0. So stopping along here. Okay. So because it's y equals 10 minus 2z, I'm actually going to start, that's going to be my first integral. That's going to be my innermost integral. It's going to be dy. And they told me it was bounded between 10 minus 2z and the xz plane. So on the xz plane, y is 0. And I'm going to have it be bounded then to this. Okay, so that's going to be my first. Now I have some options. I drew just the x and y piece, or excuse me, the x and z pieces here. And we have options. You could either go from 0 to 1/2 z if you wanted to do kind of this type 2 thing. And in which case you'd have a dx, because remember your differential is the one that isn't the variable. So if we were going to go from 0 to 1/2 z, we'd do a dx. Or we could go from 0 to 5 this way and have, or I'm sorry, from 5 to 2x this way, type 1, and then we would end up with the numbers for our x's. And I think that's what I'm going to do, because I just think that would be easier, to not have to deal with maybe the fraction in the bound. So I'm going to go from 2x up to 5. right? Because that's my, again, the bottom is 2x, top is 5. And remember, if I've chosen z as my differential, I can have a z in my bound. And again, it's just, it's kind of, you got to look down the road a little bit and say, boy, if I integrate and plug in z's and then I don't have any z's left to integrate, that isn't going to work. And then dx, excuse me. So x goes from 0 to 5 halves, which, isn't ideal to have fractions, but I'd rather have them at the end than at the beginning. Okay. So that would be your setup. Now, I'm gonna pause and just kind of show a couple of steps as I go, because I don't want to take the time to do a ton of integration here. So let me pause and do the first one. Okay, so I've taken it this far. I've done the first with respect to y, and I plugged in the bounds. All right, let me pause and now do with respect to z. All right, so here's what I've done next. As I said, I was going to integrate that with respect to z. So I wrote it down here. There are my bounds for z. Remember, if the differential is z, z cannot appear in the bounds. These two are pretty straightforward. This one I took a little substitution. U was 10 minus 2z. The derivative was negative 2. So this became a negative 3. And then when I raised the power and divided, I just have a negative out front. Then I had to plug in 5 and 2x. I did that. Plugging in 5 here got 0, and then it was negative 400x plus 200x. And then I had minus, and I plugged in 2x squared. And I've kind of combined my like terms. This is what I currently have, okay? All that was left when I plugged in 5 was the negative 200x, and this is what I have left. Oh, excuse me, this right here was a 3. Get a little ahead of myself. That's a 3. Okay, let me pause again, and now let me integrate that with respect to y. Excuse me, x. That's what's left. All right, here we are. I set it up, the integral. Of course, a lot of this was very easy, just power rule. You can see those drop down very nicely. This one I had to do a little substitution, right? So I had a negative 1/4, and then I raised the power. That's where the negative 1/16 came from. I plugged in 5 halves. I plugged in 0. And what I get is 3,125 over 6.